Somebody is there traveling?
Sir, I'm not traveling, sir.
Oh, you are traveling. Okay.
You are
Yes,
on mute. Please put
Yeah,
on mute, madam.
Yes, sir. Yes, sir. I'll do it, sir.
Okay. No, I thought to say hello to Shivsankar. I could not speak on that day.
I think she is coming back, sir.
Yes,
Yeah,
sir.
she's telling. Yeah, she's telling that she's on the way back.
Yes, sir. Yes, sir. I'm coming.
So all rituals are over.
Yes, sir. Everything, all customers are over.
Okay, take care. Take care.
Oh, oh, sir. Thank you, sir. Thank you. Sir.
Sir, shall we start, sir?
Yes. Please
you
go ahead.
you can.
Please go ahead.
Yes. Good morning, everyone. Myself, Dr. Arun Shekhar, Assistant Professor, Department of ECE, GMRIT, convener of this 6 days international faculty program.
Arun Shekhar, your voice is breaking.
Convener of this program for the 6 days international FDP on technologies for social relevance, organized by Department of ECE, GMRIT, Rajam, Andhra Pradesh, from 27th July to 1st August 2020. I feel privileged to welcome you all for this 6 days international faculty development program. Today's guests are respected Principal Sir, GMRIT, Dr. CL VRSV Prasad Sir. Welcome you, sir.
Thank you.
Respected Vice Principal Sir, GMRIT, Dr. Raja Mugada Sir. Welcome you, sir.
Thank you, Arun.
Next,
Thank you,
it's
Arun.
my great pleasure to welcome today's resource person, Dr. Ferddie Quiroz, Canlas, Associate Professor, Department of Computing, Muscat College, Sultanate of Oman, and all other 13 resource persons from various parts of the globe. Welcome you, sir. I welcome our beloved Head of the Department, ECE, Dr. M.V. Nageswara, sir. Welcome you, sir. I welcome all the heads and various of the functional units and the participants from different countries. Totally 2,200 plus participants registered for this international faculty development program. Various registration from all over the foreign countries, starting from UAE, Sri Lanka, Qatar, Oman, United States, Indonesia, Malaysia, Nigeria, also registered for this faculty development program. Now I request our Principal Sir, Dr. CL VRSV Prasad Sir, to say a few words.
Thank you, Arun. Hello.
Sir, please go ahead, sir.
Yeah. Thank you, Arun. So, good morning to all of you. At the outset, let me compliment the entire team behind this program for initiating and making the program happen. And I would like to also to thank today's resource persons, Dr. Ferddie and also Dr. Atif Iqbal for giving the consent for being the resource persons. Thank you very much for both of you. And then I also to thank all the other resource persons who will be there coming up in the next few days and making the program a grand success. In fact, the topic is almost of very much relevance, and the topic is the technology for the social relevance. Now that the pandemic, the global pandemic, has given a great opportunity and different dimension for all our academicians to think beyond what we are normally used to think in a routine way. So now that this opportunity, I'm sure that this will give a different dimension and an opportunity for the thought process to look out the technology applications for the societal relevance and how best way it can be taken up for solving and also to mitigate the post-COVID issues which may come up down the line, because the post-COVID issues are now completely in a very highly speculated manner. People are anticipating and people are predicting several things. So we do not know how it's going to happen down the line. But still, a lot of work is going on, a lot of predictions are happening, a lot of analytics are happening. And based on that, I think the way the approach towards technology development itself is going to change now, because now the approach towards development is in one way. Now it is ultimately to protect the environment. Environment protection is going to be a big backdrop on which the technology is going to take forward, because as of now, though the technology is coming up, a lot of disruptions are happening. The technologies are becoming more disruptive. So now that the pandemic has given a disruption completely globally, leading to a complete recession in the market, and also ending up in loss of lives, loss of livelihoods, and made everybody to stand on toes, think what they are doing, and what exactly will be the future. So taking all those things, I think that this platform will be a very good opportunity for all the academicians and experts to brainstorm, and also to come up with some sort of the indicative, suggestive, or advisory things, which probably people may take it forward. And I'd like to compliment all the participants who are there, who have been participating across the globe, for making it happen. And I would like to thank once again both the resource persons and also the participants for taking this opportunity. I wish you all the very best. Good luck. Have a nice day. And I'm sure that the two sessions what you're going to have will be very, very value adding, and you'll have a lot of things to carry. Thank you, Nageshwara. And thank you,
sir.
Arun.
Thank you, sir.
Thank you, sir. Thank you for your wonderful speech. Now I request our Vice Principal, sir, Dr. Raja Murugadas, sir, to say a few words.
Thank you, Dr. Arun. So let me join with our principal, Dr. Sylvia Arasvi Prasad, and Dr. M.V. Nageshwara and Dr. Arun in welcoming the resource persons and other participants from across the globe. Some time back, I informed Nageshwara, let us have someone FDP with true international spirit. I think you have made this day. All the 13 persons are almost all of native foreigners. So I'm very happy, and I think I should congratulate the organizing team for meticulously choosing the topic which is of more relevant to the present situation, that is technologies for social relevance. I think you have chosen a very good topic, and on this particular moment, I would like to congratulate the entire team of ECE. I think many programs are conducted in an organized way by the Department of ECP and along with other department. So I'd like to congratulate, and I would like to compliment all the members who are directly or indirectly involved in organizing the event. At the same time, I would like to request the participants to make the use of this program in a more meaningful way to carry forward in the coming days. Wish you all the best. Thank you, Professor Nageshwara and Dr. Arun and team. Thank you. Wish you all the best.
Nageshwara,
Sir.
I think Dr. Ferddie online, right?
Yes, sir. He is online, sir. He is
online. Okay. Hello. Good morning, Dr. Ferddie. It's very good to have you on the board, and thank you very much for giving your time.
Good morning, doctors. Thank you so much. It's a privilege. Thank you so much.
Thank you,
sir. Now I request our coordinator, Mrs. Durga Kameshwari, to introduce our resource person.
Good morning, everyone. I am Sri Durga Kameshwari, Assistant Professor of EC Department. Firstly, I would like to thank the management for giving this opportunity, and I would like to thank our HOD sir and Arun sir for making me part of this international FTP. To this 6 days international FTP, and it gives me immense pleasure to introduce today's person, Dr. Ferddie Quiroz Canlas. His educational background studied BSc in Computer Engineering in AMA Computer University and MSc in Computer Engineering in Bulacan State University. He has did his PhD in Technology Management with specialization of IT Project Management in Technological University of the Philippines, and he also did a postgraduate certificate in teaching and learning in higher education, University of Stirling. He also has associate fellow of the Higher Education Academy UK and Microsoft Certified Innovative Educator. Coming to his career, he has 14 years teaching experience in various colleges and university levels, and he has around 10 years experience in administrative activities, and he has served various positions in different colleges and universities, and he served different positions like head of the department, associate dean, as well as he has a very vast teaching experience and also 7 years experience in educational quality assurance as commission on higher educational regional quality assessment team member, and he also has 4 years full-time experience as head of the managed information system. His fields of interest include data science, artificial intelligence, machine learning, software and network engineering, and project management. Earlier, handled various positions like graduate and undergraduate lecturer at various universities and colleges in the Philippines, and lecturer at Debre Berhan University, College of Engineering, Department of Computer and Electrical Engineering, Ethiopia, and Dean and Associate Dean in Philippines. His current positions include Assistant Professor at Department of Computing, Muscat College, Sultanate of Oman, and he also teaches MSc in Big Data, University of Stirling, BCS in Software Engineering and Computer Systems and Networking, University of Malaysia, Pahang, and also he is acting as undergraduate project thesis coordinator and software engineering. We are very pleased to have you as a resource person, sir. Welcome to the FTP, sir. Thank you.
Arun? Arun?
Good morning.
Yeah, good morning, sir.
Can you hear me clearly? Is my
Yes, sir.
presentation is my presentation successfully shared in the desktop?
Yes, sir. Visible, sir. Visible, sir. Clearly visible, sir.
Thank you so much. Good morning, ladies and gentlemen. Before I begin my presentation, I would like to extend my sincerest appreciation to the GMR Institute of Technology, to the head of the management, and of course to Dr. Aaron Sikar, the one who invited me for this, and his team for giving me this opportunity to share my knowledge to you in the field of artificial intelligence, machine learning, and big data. And I would like to congratulate you in advance for this very successful event. This is really very beneficial to all of the educators around the globe. So truly, artificial intelligence is a vast topic to comprehend, and it keeps on evolving. In this topic, I would like to share to you or with you the essentials of AI, especially for educators and research enthusiasts in this area. I like the title of this conference, which is Technologies with Social Relevance. I think technology will be relevant to the society if we educators will be successful enough to mold our students, to groom them to be doing research for the benefit of the society. That's why I've tried my best to make this discussion suitable for the purpose of focusing on our students and of course we as educators on how we collaborate together to create or develop technologies or to conduct research to produce technologies that is socially relevant and beneficial to the mankind or the humankind. So in this topic, I would like to give emphasis, of course, with the paradigms. How do we meld AI with the other recent technologies like IoT and big data? And of course, as we reap the benefits of AI, we cannot avoid some challenges along the way. So which again can be turned into opportunities for us to conduct future research. So let's start a discussion with the definition of artificial intelligence. Normally in my classroom teaching, whenever I start defining AI, I usually ask my students which part of their body they like the most. So most answers I got from the students are the following. So most of the students, they will give me these answers. They like their brain, their eyes, the nose, and the heart. So these are the four major parts of the bodies our students they love the most whenever I start asking them or introducing the definition of AI. That is why it's no wonder why most computer scientists were inspired, of course, to develop AI emulating these vital parts of the body. If you will see on the definitions I provided to you from McCarthy, from Merriam, and from Goodnight, all of these definitions, the words I highlighted in bold, you will see they reflect these major parts of the bodies which scientists they like the most to simulate. So based on this input from our students, maybe they were able to enumerate brain because of its capacity to think. That's why we have plenty of AI topics pertaining to how we simulate the brain thinking. We have the neural networks, and for the eyes, for machine vision, for nose, sensing maybe, perhaps, and heart, maybe for experience. So on this particular parts of the bodies wherein scientists were inspired to simulate, that's why you will see in this definition, we could see intelligence pertaining to the brain, experience, learning, we have language, we have patterns. All of these reflect how these major parts of the bodies are working to make a human intelligent. As I have mentioned earlier, AI is a vast topic and it keeps on evolving in parallel to massive and fast improvement of hardware and software and the advancement of knowledge with other allied fields. So you will see later on as we progress with this discussion, AI is no longer alone dedicated to computer science, but to most of the allied fields, education, health, engineering, business and finance. AI now is no longer alone owned by computer scientists, but by all the fields in the industry, in the education and in the business sector. So you will see later on in this discussion why AI is no longer dedicated alone to computer science. We will see later what is the common endpoint of all these allied industries. As I mentioned earlier, AI is inspired how the human body or how the human brains and the other parts I mentioned earlier works. We want to simulate and we want to copy how exactly this parts of the body operate. If we dig deeper on the importance of these body parts, humans is more powerful than machine. That's not a question. But the human body has a limitation, specifically when the data we are processing is huge enough, and we need calculation in a very fast mode, or we need results as the earliest possible time. So in that point of view, the human body fails to assimilate this information and to process this. So artificial intelligence comes into the scenario by augmenting these human limitations with machine capabilities of doing or of processing huge amount of data, providing results in expedient way, and also performing repetitive tasks. So these are the things the human body, although powerful, cannot process in the long run. So we have goals of AI. I won't dig deeper on this because we're running out of time. But let me just give you the gist of why we have AI. As I mentioned earlier, the human body or humans themselves cannot perform things which are being done repetitively. Many studies have shown that when humans are subjected to repetitive tasks, the performance and the speed of thinking start to degrade. And also, AI adds more intelligence beyond the human capability. And like the human brains and the human parts, AI also can adapt and can do progressive learning, and it can analyze more and deeper data. I think on this point, the ability of humans to analyze plentiful of data is a big challenge, and also and to forgive is divine. So humans are susceptible to commit mistakes or to be less accurate when it comes to dealing with much amount of data and producing results at the fastest possible time or the earliest possible time. And AI helps people nowadays. We talk of big data. It helps us to get most out of data, and we can give more meaningful understanding of what this data are all about. So from the diagram I presented to you, I would like to tackle machine learning, which is my field of interest when it comes to research. And I want to narrow down a bit in the discussion. So let me give you an example how this acquired knowledge. I want you to look at the last sentence here. It says, that acquired knowledge allows computers to correctly generalize to a new settings. So let me just give you some emphasis in here why I made a claim earlier that AI nowadays is no longer dedicated to computer science, because you will see specifically machine learning, we focus much on how we get competitive and strategic advantages to data that an organization is having. So we want to contextualize the output of machine learning and AI, of course, to support the organizational strategic perspectives and trusts. If you will see, as I mentioned earlier, AI is no longer dedicated to computer science. We will see a lot of studies on healthcare. I think if there will be one field that is benefiting a lot from machine learning and AI, this is healthcare. So our dearest HOD earlier made mention about COVID. If you see a lot of forecasting and analysis of data is being done with respect to COVID. That's why I made mention earlier, healthcare benefited a lot from AI, specifically from machine learning. And a lot of the studies are being conducted in this particular area. And also in retail, in manufacturing, now in banking, customer services. I mean, those who are answering our questions are actually artificial intelligence getting data from the knowledge base of the company. So with this technique, we can contextualize the use of machine learning and AI and apply it to the specific needs of the organization. So you will see in this diagram I am presenting to you, researches involving AI now is multifaceted and multidisciplinary. You will see AI serves as the conduit or the middleman between the various disciplines. So you will have in here a collaboration of all the fields. Let's say, for example, for Internet of Things, we have mechanical, electronics, and electrical engineering, also computer engineering, all together working on that. Then we have the traditional IS, computer science, IT, information systems, and even traditional data sources can collaborate and to help us to get this information, which will later on feed to our artificial intelligence or our machine learning module. So in this way, we could have decision making for the business sector, and robotics for the mechanical engineering and the mechatronics engineering, and also automation for the industrial people. So you will see this research paradigm now is no longer dedicated to one discipline. We need collaborations among the different fields. So this is the recent research trend. If you will browse the internet when you start writing AI or artificial intelligence in Google, or even when you start typing machine learning in Google, you will see the results. The results hints will give you about big data and data science. I think all of you will agree with me on that. When you type the word artificial intelligence and machine learning in your Google search bar, the results will include big data. So this is the fad nowadays. AI is being used, specifically machine learning, to get the benefit from big data. And you will see the data analytics report 2020, they say humans consume and produce data, and therefore we need to analyze data on a scale we previously could only imagine. So we now introduce a lot of algorithms taking the most out of it, or to take the best and competitive advantages from the massive amount of data we are having nowadays. So let me give you some paradigms on the relationship of AI and big data. So I have two paradigms here. I took one from Bellinger from 1997. It's an old research paradigm. So you will see at the bottom of the pyramid, it has data, and then on the top of it, we have information, and the topmost part of the pyramid is wisdom. So we see the relationship between data and wisdom. So wisdom is the endpoint, or the byproduct of how we transform data into useful information and knowledge. So where is AI? Where is AI in this pyramid? So AI is lying between data and wisdom. So we use AI to generate information and to further give meaning to that information by converting it into knowledge. So the gap between data and wisdom is being addressed by AI. But give me the permission to modify a bit Bellinger's paradigm by changing data into big data. It's no longer data, but instead we talk about huge amount of data. And we try to answer this: what, who, when, and where, and how. And we get the wisdom on the top of it. So I would like to present to you some selected researches and studies later on with this presentation on how we convert big data into something usable. And I think I like more the version of Carpenter and Kennedy when it comes to this big data and AI relationship. It is more detailed, and it gives emphasis on how AI helps to arrive to sensible decision makings from big data. It added more if you look at their paradigm here. So again, our concern is to produce sensible decisions at the end of the process. And of course, the main goal of it is that we want to get competitive advantages. This is the main goal of every organization, to gain competitive advantages against our competitors from the amount of data that we are having with us. So the end point of everything, AI will help us to make data-driven decisions. And I think if all organizations are doing decision-making based on data, I think people or organizations will be socially relevant, or their use of information and technology is socially relevant if we make decisions based on data. And I would like to share to you some quotations before I begin with my main topic. So let me share to you one saying from Sherlock Holmes. He says, "It is a capital mistake to theorize before one has the data." I agree with this guy. And also, maybe it is a joke, but I love this joke very much, from Sir Edward Deming. He says, "In God we trust, of course, and all others must bring data." It means that for you to become relevant and believable, you have to bring sensible amount of data to back up your claim for you to be trusted. And from Charles Babbage, "Errors using inadequate data are much less than those using no data at all." And from the management perspective, I like this very much, from Peter Drucker: "What gets measured gets managed," meaning we cannot manage what we can't measure. That's why data really play big roles when it comes to decision making, and AI will help us to arrive into that. So fact 7, nowadays data is a resource, much like water or energy, and like any other resources. Data does not nothing on its own, rather it's a role changing in how it is employed in human decision making. So you will see data now is considered as a resource. So it's a very good, it's a fertile environment for us to do researches, incorporating how we dig deeper to big data and meld it with AI. So let me start presenting to you the first technique. So if you will notice, going back with the topics that I have presented to you, I've selected, I think, around 4 major techniques which are very essentials, and I think those techniques that I'm going to share to you this morning will be relevant enough for your students to write researches which will benefit our society. So I have chosen these 4 essential techniques. I call them essential techniques because from these 4 techniques, other advanced and more complex techniques evolved. So if you will see, most of the advanced techniques in AI, they came from these 4 essential techniques that I'm going to share to you. So let me present to you the first technique by giving you a case scenario. And let's help this manager here. let me just read to you the transcript. I am selecting from the shortlisted applicants for the MIS manager. So we're looking for the MIS. So we have 3 applicants. Help me to select, please. So we have these 3 applicants. So looking at this varying attributes, let's call it attributes, it is really difficult to decide, right? Having these 3 people having different educational levels, level of educational background and working experience and also expectations. It is really difficult to decide, right? Having these 3 people with us applying for the same position, possessing all of these qualities and attributes with them. So if I'm going to ask you to decide on this, perhaps we have varying perspectives on this. Some of you may go biased with the educational background, and some of you may go biased with the experience. But at the end of the day, the management, specifically the HR, will focus on the financial implications of this, right? Which is the salary. So the point here is that it is really difficult to perform decision making involving a lot of conflicting attributes and a lot of conflicting qualifications from our applicants. So let's narrow down the qualifications or the criteria. Again, I'm shortlisting applicants for the MIS manager position in the company. Now, this time we have a measurement, we have a measuring rod to determine which pass and which fails the selection. So this time we are qualifying, we are providing minimum requirements, MSc in big data, and at least 5 years experience, and a salary expectation is OMR 1,800. But again, giving this criteria at hand, it made the selection a lot difficult, right? Because if you will look at them, I think nobody will pass this criteria. MSc in big data, at least 5 years experience, and salary is 1.8. So we don't know which among these applicants is at least nearer to the criteria set beforehand. What if the scenario is like this? The scenario is like this. Given the parameters like that, like those, the criteria for selection, it made the selection very difficult or complex. But this time, we don't have only 3 applicants, but we have 1,000 applicants in the website. So how we will now select? How we will now select the applicant for this? So when I teach my students in the MSc in the big data, when it comes to complex decision making like this based on criteria, I usually suggest CBR. So CBR, or case-based reasoning, is a branch of artificial intelligence. So it has this what we call knowledge base, and the approach focuses mainly on retrieval and reuse of solution. So I suggest this technique for 2 compelling reasons. First, CBR, provided with ample criteria and weights, it can act like a human expert. It can do analysis like a human expert. And good thing with CBR is that it has easy implementation, and we are not required to write series of if else, if else, if else, if else, if else. But instead, we have to represent each attribute or criteria into series of rows and columns in our database. So case-based reasoning has 4 major processes: retrieve, reuse, revise, and retain. So we have a new case. In that case, we are trying to look at which among the applicants will fit the criteria. And those 1,000 applicants were in our knowledge base, and we try to look and compare which among these applicants will satisfy the requirement. So from there, we have to retrieve them, and then we have to look at which one will match the criteria, and we have to reuse it. If we think after retrieving and reusing, we did not find it fitting, the suggested solution is not fitting, then we have to revise it. We have to modify the solution, and then that modified solution will be retained. Both the modified version of the solution and the new solution is added to the knowledge base, or it's being retained to the knowledge base, and we call it learned cases or learned experience. And if you will see, CBR is delving much with the retrieve phase. So much, if you will see later on, much of the processes in CBR, I think around 90% of the processes are focusing much on the retrieve. And in this retrieve phase of the technique or the algorithm, we are focusing on the similarity comparisons. So we want to check, we want to compare the traits of the new problem, the attributes of the new problem. We want to compare it with the existing list of problems we have solved in the past, which are now residing on a knowledge base, usually a database, as we mentioned earlier. And from there, we try to check the degree of similarity of this new problem with the existing ones, the ones we solved in the past in the database, and try to apply the solutions to that problem. In CBR, we have the presumption or the assumption that problems having similar traits, at most similar traits, will have similar solution. So you will see as the system accumulates a lot of information, CBR becomes more intelligent. I mean, it will possess more intelligence and it becomes more intelligent. That's why when it comes to experiential way of analyzing results, I suggest CBR to be a focal point when it comes to analyzing data and produce decision making. So CBR utilizes global and local similarity, which are again mathematical in nature. So in my classes, I ask students first to do the mathematical manipulation for them to understand how the algorithm works before we go with software-based calculations. So it's very important that our students understand the manual calculation before they go with the automated version. And a good thing with the 4 techniques I'm going to present to you, you can implement them with simple programming languages, and there are a lot of libraries available now in the community where you can download these libraries and reuse the codes, and you don't have to write them on your own. So our students will benefit a lot from these libraries. But the starting point is that students should understand the inner workings of the algorithm. So good thing with CBR, it both works with discrete values and continuous values. I think this is the major limitations of the other algorithms, specifically, let's say, for example, neural networks, fossil logic, and genetics algorithm, which I'm going to discuss to you next. The disadvantage of those algorithms I made mention, they are numerically focused, meaning they cannot manipulate values which are expressed in nominal, let's say, for example, male, female, or let's say, for example, married, single, PhD, MS, BS, or MSc, BSc. So those values, they cannot handle. So you have to translate these values into numerical ones. So good thing with CBR is that it can directly manipulate these things. So the formula, again, is mathematical. So first we have to go with the local similarity. It means when we say local similarity, we try to compare each attribute. Okay, we break down the problem into attributes. And when we say local similarity, we try to compare these attributes. The age versus age, gender versus gender, educational qualification versus educational qualification, working experience, expected salary versus expected salary. So that's local similarity. And from this local similarity, we try to conclude and we try to summarize it by calculating the global similarity. So the global similarity cannot be calculated unless and otherwise we finish calculating the local similarity. So the global similarity would like to look now with the individual cases. If local similarity is focused on the attributes, global similarity is focused on the cases as a whole, meaning applicant 1 versus applicant 2 versus applicant 3. Unlike with local similarity, we are comparing the age of applicant 1 and the age of applicant 2. So those are the major differences between the two similarity comparisons. And both of them, they require some mathematical assimilations. So reuse, revise, and retain will be the latter phases of the algorithm. And when a new case is revised, it is being retained in the knowledge base. So it will make the system learn and becomes more intelligent as time goes by. So CBR is becoming more reliable the bigger the knowledge base becomes. So meaning the more rows of data we have in the knowledge base, the more intelligent CBR would be. That is why CBR is a very good algorithm to use when we work with big data, many rows of data, and we want to make comparisons on those. So classical examples you can give to your students. Let's say, for example, we have E1 up to E18 in our database, and we want to predict the behavior of our users in our website. Let's say, for example, you're trying to create an analytics in the website and you want to check and to determine the behaviors of our readers in the website. So this is a very good example. So if EX, let's say, for example, the reader has these attributes, unknown, follow-up, long, and home, what would be the user action? What would be the attitude of the user? Would it read or skip the article based on this attribute? So from this existing rows of data, E1 up to E18, you would like to predict what will be the behavior of the new user or reader in our website. So we can also use CBR when we go with forecasting. We can do forecasting. Given the set of attributes, we can determine what do you call this one? The action, the future action of the user. I have made experiments comparing multiple linear regression and CBR. And in my experiments, I found CBR to be more reliable than multiple linear regression because multiple linear regression is affected by some other factors. Unlike with CBR, CBR is much concerned with the attributes and the weights. And CBR is quite closer to the results of fuzzy logic comparing to linear regression. And linear regression is unpredictable on some ways when it comes to predicting the output. So let me give you one excerpt from the research paper. Dr. Aaron, kindly remind me of the time. If I am on the half of the time, kindly remind me so that I could manage my time, because I don't see my clock in my laptop. Kindly remind me if I am reaching half of the time. So for the excerpt from a research paper, I would like to share to you my research paper. I made a data mining model for a student internship placement using modified case-based reasoning. It was presented in a conference and published in Springer. So I'd like to share to you an excerpt from that. So the proposed model that I presented in the paper utilizes the retrieval process of CBR. Again, it's quite synonymous to the case scenario I presented to you earlier. So in this time, we are trying to compare the students' attributes. And I think the prototype of this paper, I brought the software and the prototype, and we submitted it as a funded project here in Oman. We would like to implement this in Oman. So we want to provide a collaborative communication platform for students, HEIs, and organization. So the proposed implementation is a cloud-based, and it's a collaborative architecture. So the focus of these studies will be students, higher education institutions, and industries. So we want to provide a channel for posting, searching, and applying, placing, and providing internship programs. Because here in Oman, what we have noticed, internships are being sent via email. And then these emails are being forwarded by the concerned departments in the college to respective students who wants to get internships. So this is a little bit tasky and manual. So sometimes if the email goes to the bottom of your email, what happens is that most of the time we neglect it. So in this example, I made sample selection criteria, and then we focus on the weights to determine or to give emphasis on the criterion of much importance. Let's say, for example, an organization may give much attention to course and GPA and lesser with age and gender. So the software written was dynamic in nature, wherein we are not limited with this criteria alone or these attributes. We can add more on this. The system is capable on accepting those. Let's say, for example, the organization that wishes to take students for internship, they could set criteria like this. Let's say, for example, they want to absorb students from the IT, having IT background, gender is male, age is 20, and GPA is 3.5. And look at this one. So they give preference to the course with 2 as the weight, and gender lesser with the gender, age lesser, and the GPA as 2. So meaning if the applicant is female, it won't much affect the selection. So this is the sample of the querying of the knowledge base. So we could select all the students from our database, and from there, let's say, for example, for the test case scenario, we have students A, B, C, D, and E. All of them are IT because we selected from our SQL statements. We want only the IT. So business students will be eliminated from this. So assuming that students already entered all the information from this platform, so all of their information will be returned. So again, let me emphasize on this, that the attributes are not limited to name, course, gender, age, and GPA. It can also be on addresses, on locations, so on and so forth. But for this test case scenario, I want to emphasize only on this 4, just to have the brevity of the discussion. So for the test cases, we have the initial results, and applying the calculation for local similarity. Let's go first with gender. Since gender is a discrete value or nominal in nature, we could directly go with the comparison. If the similarity, if A is equal to B, and then it will be 1. If A is not equal to B, it will be 0. So if we will look at it, the company is looking for students IT and male. So the first, all the applicants will get 1 on this, on the course, and gender will be 1, 0, 1, 1, 0. That's why the result is like this. So if you will notice, CBR will convert values, realistic values, into values between 0 and 1. Because we know for a fact that values between 0 and 1, aside from this is the default language of our computers, dealing values between 0 and 1 is a lot easier than dealing with values having 5, 6, 7 place values. So it will help us to calculate it a lot easier if we convert all of these values into 1s and 0s. So for the continuous values, we try to calculate the age and the GPA using the formula here, A minus B over the range. So the result of the calculation, actually you can do it manually in Excel. Your students can do experiments on this and manually calculate it in Excel and do analysis on their own after that. So if you will see, all of the students, when it comes to course gender, we have 1, meaning 100% similarity when it comes to the course for the local similarity, 100% for the gender for students A, C, and D, and 0% similarity for students B and E. So for the age, student A got 75% similarity with the criteria set by the organization. Student B 100, for same with GPA. So these are the comparisons vis-a-vis the criteria and the student's attributes. Now let's try to go with the global similarities. In the global similarities, you will see that 2 students got 82% similarity with the criteria by the organization. So it's all up to the management. It's all up to the hiring committee. To the internship hiring committee to decide the threshold. Let's say if the threshold is that if they want to select all students who got 80% above similarity with the criteria, then they could absolve them and accept them for internship placement. So that's also addressed in the system, in the software I have designed. So basically, student 1 and student 3 will be eligible for internship placement based on their similarities with the criteria set by the organization. So there is a useful tool that your students can use to do experiments in their class when it comes to CBR. You can download it from this link and your students can do experiments. But again, I would like to encourage you should understand first the inner working of the algorithm before they go with the software. Because I have noticed that those students who were able or were successfully done the manual calculation were able to easily understand the software without even giving them orientation, because they understand, or they understood the inner working of the algorithm. Let me proceed to the next technique. So normally I show pictures like this in my class whenever I ask students to, whenever I introduce the topic to my students and I ask them which one is crocodile, which is alligator, which is tiger and a lion, and which is a turtle and a tortoise. So most students will give you answers, of course, on how they identify the differences and the similarities with the images. So if you will see, there are some confusing or fuzzy attributes when it comes to the two entities we are trying to compare. Let's say turtle and the tortoise, crocodile and alligator. So this can be also expressed in this way. Let's say, for example, we have this series of people. We have the person here having the height of 5'1", and the other height here, which is 6'4". Expressing this into binary number, it's very easy. The smallest one will be 0. The tallest one will be 1. That's very easy. Boolean algebra or Boolean expressions, it will have 0 and 1. 0 means not tall, 1 means tall. But our problem now is, let's say, for example, let's look at 6'1". For the case of 6'1", is 6'1" tall or small? We don't know, right? It is unfair to say that 6'1" is tall because 6'2" is also tall. It's unfair to say that 6'1" is small because, in fact, 6'1" is taller than 5'1". So in this case, there is fuzziness, there is confusion in the representation of the data. So in this case, in this kind of scenarios, fuzzy logic is best fitted. And if your concern is converting nonlinear values, let's say real world values, into scalar output, of course, guided by rules. Again, let me remind you, fuzzy logic is a rule-based algorithm, meaning it can't work without rules, which is again the disadvantage of fuzzy logic over CBR is that fuzzy logic is highly dependent with rules. It means that if your rules are wrong, then fuzzy logic will fail. So fuzzy logic consists of four main parts. We have the falsifier, the rules, again the rules, the inference, and the falsifier. Falsification is just simply we want to convert real life values. We call them crisp real life values. Let's say, for example, 1,000, 5,000, 3 million, 75 Fahrenheit, 1,000 centimeters on 1 kilometers. We can convert these values into values between zeros and ones, and we call that process falsification. And of course, falsification requires some mathematical manipulations. That's why you have to construct some membership functions in there. So the membership functions will help us to convert real life values into values between zeros and ones. So these membership functions I'm going to present to you later on. And after that, we have to subject these falsified values into our rule base. And from this rule base, we want to draw some inferences. And from these inferences, we have to defalsify, meaning from 0 to 1, we have to bring back the value into original real life understood values. So from zeros and ones, we turn it back into something usable, something understood by the user. So meaning at this end of the system, it is human understood. At this end of the system is human understood. This portion of the system is both machine and programmer understood applications. So at the end of the day, we want the end user to benefit from the decisions generated by our inference engine, of course, based on the rules we specified. Again, let me emphasize this. If our rules are not correct, the inferences to be generated by fuzzy logic will be also not correct. Let's always see the GIGO principle. This is the major drawback of any AI system. It follows the GIGO principle. Garbage in, garbage out. If you feed the system with garbages, expect the system to produce garbages. That's one limitation, major drawback of any AI systems. So, falsification and defalsifications are the two complex processes any programmer will encounter when it comes to designing of the FLS or the fuzzy logic system. So we need to do some mathematical manipulations here. So we have trapezoid, triangular, Gaussian, and singleton. For highly complex applications like signal processing, you can't go with the Gaussian membership functions. But for your students, trapezoid and triangular are enough for them to write applications and to do researches applying fuzzy logic. Trapezoid and triangular would be enough for them. So this is how we convert our crisp inputs into fuzzy sets. If you will look at the bottom part of the diagrams here, let's say, for example, in height, 150, 160, 170, 180, 190, and 200 are the real life values. After falsification, the one I mentioned earlier, after falsification, these values will be converted either into 0.0, 0.2, 0.4, etc. Any values between 0.0 to 1.0. So converting again these values, because in the future, you might be encountering values larger than this. This is quite easy to handle, right? 150 to 210. But if you are handling thousands and billions of values, this is quite complex for human beings to handle. So the solution there is we have to convert it again to values between zeros and ones for easy manipulations later on. So the triangular membership function is very easy to understand. Any values that lies or any value that lies between A and B will be following this formula. A and B will be x over A divided by B minus A. So this would be identified in your diagram here. For the triangle, this one represents A, this one represents B, this one represents C. So for us to convert any value that falls between 165 to 185, we have to follow this formula here. X minus A, B minus A. This is A, B, and C. So any value which will be your X can be converted into ones and zeros using this formula. Similarly, for trapezoidal value, any values that fall between A and B will also follow this formula. Any value that falls between C and D will follow this formula. So for us to better understand this, let me give you again another research problem. So this was a research paper presented to me by my students in Ethiopia in Debre Berhan University as his MSc in computer engineering project. He developed a fuzzy logic system for intelligence car speed control. And the variables involved in his study was the temperature and the cover. So because in Ethiopia there are some areas or regions in Ethiopia where the temperature is very cold. So driving is really dangerous, specifically for areas having zero visibility with fogs. So sometimes roads are covered with fogs and it's really difficult to drive. So the students would like to design a system that could help or assist motorists or drivers in controlling their speed. So there are three variables involved in his study: temperature, cover, and speed. So these are his membership functions. So for the temperature expressed in Fahrenheit, he had 10 up to 100, and for the fogs, the cloudiness of the sky, he had it expressed in percentage from 0 to 100. So his output, the output or the decisions to be produced by the fast logic system is categorized into two only, either to be slow or fast. But how slow is slow and how fast is fast expressed in miles per hour. So good thing with faster logic is that we're not limited to two values alone, which is slow and fast, but it gives us a degree of how slow and how fast driving would be in this scenario. So his rule base are the following. So according to the student, if it's sunny and cool, he wants to the driver to drive fast. Same with the other rules. If it's cloudy and cool, the driver should drive slow. So these are the rules he generated, and from here, the fast logic system will draw inferences or conclusions. So this is the sample test case from his experiment. So the input is 81 degrees Fahrenheit and the cloud cover or the fog is 23% cover only. So what would be the output of the system or his system? So in falsification, during falsification, we converted 81 degrees into these values, but this time there is now confusion or there's now fuzziness. As I've told you earlier, it's like comparing lion and tiger, alligator with crocodile. This time, 81 degrees Fahrenheit falls into two categories. It's both hot and warm. Looking at it, 81 degrees Fahrenheit is 55% hot and 45% warm. So there's now a confusion here. And for the cover, 23% is both 85% sunny and 1% cloudy, something around this figure. So evaluating or producing inference from the rule base, we need to evaluate it. So from the evaluation, there are two rules that the input satisfied. So sunny and hot, cloudy and warm. So from these two rules, we'll try to perform further action by doing ANDing operation. So in the ANDing operation, since we are using AND, we have 0.55 fasts. And for the other rule, we have slow, which is 0.1. So since we are working with AND operator, we know for a fact that AND operator will always follow the conservative one, right? In the AND operator, it's like doing multiplication. The smaller value will override the bigger value. So 1 and 0, definitely the answer is 0. So ANDing 0.55 with 0.1 using the principles of AND operator. So 0.55 will be defeated by 0.1. So we will follow 0.1 later on. So in this situation, we will be using centroid or the measure of central gravity. And we will try to defalsify now. Try to defalsify. So in the defalsification, we'll be using the speed 63.06. So which is, if you look at it, 63.06 is lying on the slow region. That's why I told you in the ANDing operation, the lesser value will override. So the 10% slow will override the 55% fast. So in this case, we will be having 63.6 mph. So your student can do the manual calculation of this so that they would understand the inner workings of faster logic. And after that, they can go with the programming side. So your student can use the JFast logic. You can download it for free. It's an open source. So your students can write codes like this, and they can see the output like this at the end of the lab exercise. So the membership functions will be generated, and the classifications will be shown here. So my student, Muaid Al-Falahi, both of us, we collaborated and we wrote a project. This time we combined fossil logic and big data. So we will be presenting this paper on the third IEEE. It will be on, I think, second week of August, God willing. So we wrote a project for the Al-Nakil tree, or the dates tree here in Oman. And again, this project is submitted for a funded project for the TRC. Will be submitted. I mean, the students have submitted it as a project in the TRC, and we will be waiting for the result. Basically, in this study, we work with the Ministry of Agriculture and Fisheries to get the data on how to cultivate the palm trees for the dates tree. So this time we are proposing an architecture wherein it's a cloud-based, and we keep on recording the information sensed by the various sensors we employed in this project, and we try to process the amount of water using fossil logic. And on some scenarios, let's say for example, it's unavoidable that one of the sensors failed. So our system will switch from fossil logic into trend analysis. So using the moving averages method, we are going to retrieve all the information that the Arduino have saved in the database, in the cloud. And from those trends, we're going to analyze the trends. And from there, we're going to take the moving average of those sensor readings and amount of water supplied to palm trees on a specific period of time. And then from there, fossil logic will be replaced by the results by the trend analysis. And the Arduino will switch from fossil logic into trend analysis the moment one of the sensors have failed, which are not working. So the fossil logic rules, we have this, and based on the complexity, if you will look at it, the rules are very complex because the Ministry on Agriculture and Fisheries have given us the range of water of the palm trees depending on the age and the scenario and the type of the plant and the type of the soil, and based on the situation. So we formulated these rules. So it's quite complicated when it comes to the formulation of the rules. So your students can use this tool. You can download it from jfossologic.sourceforge.net, and you can get this very useful tool your students can use in the future for testing their prototype. And I think most of the studies I have reviewed, last time I received some review papers from the Open Computer Science Journal, and most of the papers I'm reviewing nowadays, they focus more on image processing, identifying differences on the images and extracting information and associated data with images. So convolution artificial neural network is very famous nowadays, and most of the studies I am reviewing are falling on this. There are a lot of studies focusing on image recognitions, and mostly on food processing, especially on diet likes projects like that. So convolution artificial neural network is a very good algorithm. You can train it either using supervised or unsupervised learning, and it could help you to identify, extract information from images. But of course, this subsume of convolution artificial neural network, may be deep learning or supervised or non-supervised, they came from one mother algorithm, which is the artificial neural network. Again, I'm always emphasizing this before your students go with the higher level and complex algorithms like those I mentioned earlier, like let's say for example convolution, artificial neural network, they have to understand first the inner working of a very simple neural network. So they have to understand at least the inner working of the weights, the biases, and the perceptrons. It's very important before they go with the higher levels, because if they won't get the basics of it, it's really difficult for them to assimilate the complexity of those algorithms. So as I mentioned earlier in the examples, artificial neural network is very good to use with vision, conditioning, pattern recognition, classification, and clustering. I think we have a lot of software available in the internet, both proprietary and open sources, for our students to download and utilize in their experiments in the classroom. So our students should understand these methodologies: data collection, data normalization, neural network design, neural network training, and testing. So on this first step of the methodology, data collection is actually the area big data will play into. Data collection. We have huge amount of data, and you can store this data using the available technology nowadays. We have Hadoop, and you can process them later on using Spark or MapReduce, and even with Python. So those tools are readily available when it comes to data collection. So even on number 2, 3, 4, and 5, we have available softwares and technologies, and can be downloaded anytime. And most of them are free and open source. Our students can use them, their experiments. So in the data collections, normally we represent the data into rows and columns. That's why I told you earlier, this could be from your big data database or any ordinary database, and you could present data like this. So in this example, we represented the data into double or float representations, but in real life this data can be more than these values. And sometimes, I told you earlier, data can be represented into nominal values, let's say for example wide, medium, narrow. So you have to further convert this data into numerical values. So in after doing the data collection, you have to normalize it. Normalization is the process of converting your data from real life value into zeros and ones. If you'll notice, most of the algorithms I presented to you, they normalize data between zeros and ones for easy handling later on. And after that, you can now design your neural network. So you could ask your students to start with basic XOR. Let's say, for example, your students can work on this as an experiment, as a starting point in learning artificial neural network. So in my classes, students are actually doing the manual calculation of this. And after that, I ask them to write programs in C#, in Java, or in C++, converting the algorithm into a working code. So this is a very good starting point for students. So we ask them to perform the XOR operation. So basically, the XOR operation, meaning any values, if the values are both or similar, they will get 0 here. Anything in between will be 1. So students can do something about this. So in the neural network training, our main goal is to calibrate the weights, meaning the accuracy of the recognition, may it be a pattern or a learning, of our neural network is focused more on the weights, meaning if the weights are properly calibrated, and then our neural network will produce accurate values. So you will be doing series of forward and backward propagation. So in the forward propagation, we apply set of weights, calculated, sum of weights, so on and so forth. In the back propagation, we now adjust the weights based on the margin of error we obtained from the calculation. So this is an iterative process that if our students will do it manually in the calculation, they will take time in arriving with the right answer. So for the sake of assimilating the inner workings of AN, I usually ask students to do 2 iterations of the forward and backward propagations in the calculations, and the rest they have to do it on the programming side. So in the forward propagations, we have the activation functions, which the students will use. So the most commonly used one is the sigmoid logistic. So most students, they can train simple AN using the sigmoid logistics with this formula here. For highly complex applications or image processing and the likes, you have to go with the hyperbolic tangent. This is beyond human calculations. I think students can no longer perform manual calculations on here. So we need software to assist us in dealing with the results. So in the back propagation, we are required to perform series of calculus, mathematical calculations, and most of the time students will take most difficulty on this area, specifically if the students are not that good in doing mathematical manipulation. So this is very important that the students have very good background in mathematics in order for them to do the manual calculation, because on is like it's a chain process. If you will commit mistake on one stage, then the rest of the outputs will be wrong. So students should be extra careful when it comes to the back propagation, because here we are adjusting the weights based on the error. So a lot of mathematical assumptions and manipulations will be done by the students here. So adjusting the weights will be following this examples calculation. So there are useful tools. I mentioned earlier, there are some calculations in AN which students cannot perform manually. So this time we have to move to more advanced tools like Anaconda. We have Python, NumPy, sklearn, and Graphis to help us on that. And we have Weka. I think the most popular tool from University of Waikato in New Zealand, I guess. So we have these helpful tools. So students can perform mathematical manipulations here and even show graphs they are concerned with clustering. When I was young, when I was in my high school days, I always asked my teacher and also myself, why do I need to study algebra? And what does this A, B, C, D, and E in an algebraic expression? What do they mean? What are the relevance of this? That's why I keep on saying, where can we use these variables in the future? What will be the use of this? And then as I grow older, I realize that sometimes in life we have to express things into algebraic equations like this. The famous example I'm giving my students, the knapsack problem. So this problem here can be expressed actually with this algebraic equation. How many A's having 12 plus B having 1 and C having 4, D having 1, E having 2, and I place in a bag to have a total of 15 kilograms. So these are the, I think these problems are actually what do we call the minimization and maximization problems, right? Best examples of minimization and maximization problems. We try to express the problem into algebraic expressions like this. I think this will answer my questions during my younger years when it comes to my algebra time. That is why I'm not blaming my teachers in the past when it comes to this, but my point is sometimes we professors we fail on giving the practical application of what we teach in the mathematics. Because if students won't understand the social and the practical applications of mathematical equations, they will hate mathematics and they will find the subject boring if they won't find it practical and useful in their daily lives. So whenever I teach algebra, I start showing this with my students, and from there I begin discussing what are the A, B, C, D, and E, X, Y, and Z in the algebraic expression or equations. So when it comes to optimization problems, genetic algorithms are very good to use. And genetics algorithm was introduced by John Holland in 1970, and it is inspired by how the human genes affect the overall quality or the overall being of a person, right? So a person coming from parents sharing the same weaker genes or chromosomes will likely produce an offspring having weaker compositions. So this is the concept of genetics algorithms. It is like I can link it with the survival of the fittest, I think, with two theories of genetic evolutions. We call it the survival of the fittest and the what we call the selections. So those who are fit enough could survive, and those who are not fit will be eliminated. So we select the most fitted one and combine them to produce better solution. So genetic algorithms have steps. Again, we have to represent the problem variable domain as chromosome of fixed length, place them in the population we call N. So in that population, later on, we're going to select which will qualify to the next round by subjecting them into a certain fitness function. It is like saying in a plain English, every problem may have 1, 2, 3, 4, or n subset of solutions. But the question is, are all those solutions good enough to solve the problem? So the idea of genetic algorithm is that we try to eliminate the solution that is seemingly not good enough to give us an ideal solution to the problem. Try to select those who may help or which may contribute in arriving the ideal solution, and we try to combine them. So in selecting those qualified chromosome, let's call it chromosome, let me call it chromosome. Chromosomes are actually the representation of the seemingly visible solution in genetic algorithm. We call them chromosomes. So these chromosomes, we subject them into the fitness function. We have the fitness function. And then from there, we have to select the chromosome that will be mated or will be combined later on and becomes a parent. So from here, we randomly generate an initial population of chromosomes of size n, and you're going to calculate the fitness of each individual chromosome. What is this fitness? This fitness is actually an algebraic equation similar to what I have shown to you earlier. You can express your problem into algebraic expression like 3a plus 3b plus so on, etc. and etc. And from there, we will try to subject all these initial solutions and try to eliminate those which are not reliable enough or give us the nearer solution to problem. And then after subjecting all of this function, we are going to pair, the chromosomes or the solutions. We call it mating. And then these feasible solutions after mating, we put them again into new population. And after putting them into new population, we will be doing some genetic operators, which is crossover and mutation. We know for a fact when we go with mating, let's say with the parents, with the mating in the parents, maybe your parents, your mother is good in dancing, your father is good in singing. So in mating, we will be producing a new individual, right? So the possibility is that that new entity will be either good in singing or either be good in dancing, or it can possess both. So that could be the process or the byproduct of the crossover process. In the crossover process, the new chromosome or the new individual, as we call it in the layman's term, might possess one of the characteristics of the parent or can possess both. There are some situations wherein the new chromosome is good in singing, good in dancing, and there is a new attribute. Let's say, for example, he's good in math, but none of the parents were good in math, right? So most probably that's the effect of what do we call mutation. And a mutation is actually the byproduct of touching one of the genes of the new offspring or the new individual, as we call it. And that mutation may produce a unique characteristic driving into a unique solution and better solution. So if you will notice, genetic algorithm is an iterative process, repetitious process, wherein we try to do the same process again and again and again. And as we go with the iteration, we are producing perfect offspring and a solution perfectly fitted to the problem we're trying to solve. So on the 10th step, you have to go to step 4 until the criterion is satisfied, which is the equation you want to solve earlier. So I would like to take one example from the case study of Ferddie in 2013. So he made a study on, he showed an example on how to solve mathematical equality problem using genetic algorithm. So he proposed a system wherein you could input a mathematical equality, and then the genetic algorithm can show what are the variables of x and y, z, and you'll arrive into the final answer. So the genetic algorithm was able on doing that. So you will have initial population, initial values, yes, on what would be x's or the value of x in the equation, and from there you have to place them in the population, and you have to subject them into the probability function. which is actually our problem, 15x minus x squared. You'll notice later on some of these initial solutions that we have will be eliminated as we go with the fitness function. So from here, you will see after doing calculation, you will see the fitness ratio. So x2 plus 22, then x5, and x6, 25, and you will see it here the fitness ratio after subjecting the initial solutions with this equation. And from here, we'll be doing selection. Among those who will be eligible enough, the next round, which is the crossover, I mean the mating and the crossover. In the mating process, we will be doing crossover. You will see here x6 and x crossover, x1 and x5 crossover, x2 and x5 crossover. And after doing crossover, we will arrive into a seemingly clear solution to the problem. After doing the crossover, randomly, we'll be doing the mutation here, touch one of the gene, then it will produce again another unique solution. Then from there, we repeat the cycle. That's one. And a generation IF36. By the way, our target here is we want to get the maximum value for the equation. So you will see the equation, I mean the process keeps on iterating until such time satisfy the value for the said equation. So there are useful tools our students can use, and actually this is a library for our students to use when they go with page processing. And I asked my students actually to integrate it with Java and C#. If our students are good in Java, they can have option, and if our students are good in C#, they can go with this. So this is a very good tool for our students to experiment with when it comes to image. So I am working on Dutch, Philippines. I'm trying to find learning techniques and also big data in here. So sentiment analysis, how to use data. Yeah, IoT at level, weather forecasts, and from here I'll be using the process system, so system. And from here we will produce the advisory. Because in the Philippines we have a common problem that our country is affected by typhoons, call them cyclones, storms. We think we have less a minimum of 10 typhoons every year. The common problem in Facebook, Twitter, and in Instagram, people are complaining about the suspension of working classes. Is the government has in the locality, the local government fails to announce the suspensions of class work time because the weather forecast from the national government is not reliable. Sometimes the area or the region is subjected to signal number 3. Signal number 3 means cancellation of classes. And what's really happening is that although the region is subjected to signal number 3, there is no even signal of rain and wind. No, signs of rain and wind. In that case, the weather forecast is failing. And sometimes the region is, this one is subjected to signal number 1, meaning classes what government are normal, meaning normal routine, this are useful, undefined. But the real scenario is rain is very strong, God is everywhere, and people now start to Facebook, but knowing the signal is not 1. Meaning there is this discrepancy between what's being said by the weather news and what being produced by the sentiments in by the people in the media. and also the locality itself. We cannot go to the locality, not not being seen in action by local government. So in this, I'm trying to write research together and find all of this that to find. I told you these four techniques are essential enough for us to write a research paper. So before I end up my presentation, I would like to post the talent out these are another this. So artificial intelligence is going to change everything, but and its limits to the ethical and ethics have high legislation issues. And the limitation of AI is that then data. Without data, AI is useless. So there is no other way which knowledge means any inaccuracies in the data will be controlled and any error in analysis are in that way British should do higher. Today's AI systems need to be really different up. This is the advantage of AI are really designed for job are specialized. So we start, for example, the system that plays can't play for the value that detects in a five deep parts. We have that detects one of the in a this is very large. They are high software autonomous system, although we keep very of learning. Yeah, trying to do systems like those, reality is as perfect. We might be learning to have margin that we in reality are learning and to perfect like live.
Hello, sir.
Hello.
Thank you, sir, for your wonderful presentation. Sir, is my voice clear, sir?
Yes, I can hear you clearly.
Yes, sir. Thank you. This is Suresh, sir, Assistant
Thank
Professor
you.
of History Department, Coordinator of this program. It is really a splendid presentation, sir. You started focusing on a CBR problem and then moved on to fuzzy logic system and thrown some light on convolution neural networks. And many of the times when we listen to this AI topics, many of the people will go on with image processing problem. But you have come up with a new problem idea and shown to our participants how we can address CBR issues, as well as we have thrown some light on fuzzy logic systems, sir. And the participants also felt the same, sir. They are active and they told that the session is very informative and they liked the session. And we have few questions, sir, from the participants.
Please, yes, please.
One question is from Mr. Sanjay Singh. He asked to describe neuron technology.
Neuron technologies, huh? That's the question.
Yes, sir. Neuron technology.
So neuron technology is one component of the neural networks, and actually the neuron actually is the real implementation of the human brains. Actually, that's the neuron. But in the AI, the neurons, we call them on a different term. We call them the synapses. Okay, and from there we have the interconnection. So these neurons, let me just share my screen so that we will just see what I'm saying here. Can you see my screen now, sir? Can you see my screen now, sir?
Yes, sir.
Okay. So neurons in the neural network actually are the interconnections, even in the brains of the human beings. The one that actually does the performing in a calculation, image recognition, or whatsoever it is, are actually the neurons. The neurons are the ones responsible for interpreting signals from the input. So we have the inputs here. Also, again, these are types of neurons that their job is actually to get inputs from the outside world, and it responds to the stimuli. And these neurons are interconnected by synapses, and these synapses are actually activated. They are activated, and they respond based on the corresponding weights. So in a nutshell, just to give you a very short discussion on this, in the neural network, mathematical calculations, activations, forward propagations, and the forward and backward propagations, adjustments of the weights are actually dictated by the neurons. Okay, so all the mathematical equations I have shown to you are actually conducted on these neurons that are interconnected with your system. It means that the more neurons your system is having, your neural network is having, the more intelligent your system would be. A caveat in here, the more neurons, the more mathematical computations you're going to make, and the more complex would be the calculations, and the more complex would be the design. Similarly, in the human brains, if the humans, they say it, as we go older, some of our neurons, they die. Okay, so the brain has plenty of neurons, billions or even millions of neurons. When we are born, we have millions of neurons. That's why the assimilation, the learning rate, and the training rate of a young child is faster and accurate comparing to a person who is getting older, because the number of neurons decreases as we go older, and that will affect how we learn and how we calculate things. So similarly, in the neural network design, the more neurons you have, the more intelligent your system would be. If you will see in this example, we have only 1, 2, 3, 4, 5, 6 neurons in this example, because we're only calculating very simple problem, which is an exclusive OR. It's very simple to calculate that. But with real life application, as I've told you earlier, you might experience working with multiple layers of neurons. And again, calculations will be complex and it will be beyond our capacity to calculate it manually. In that way, I am suggesting you now to go with computer assisted calculations, and you can go with the software I have given to you earlier on. So I think that would be the easiest, the simplest answer I could give with a question. Any other questions, sir?
Sir, another question is there, sir.
Please.
Biomedical engineers, what are deals with artificial intelligence?
Come again, sir. I didn't get the first part of your question.
Biomedical engineers, what are deals with artificial intelligence? Maybe
medical
engineers. Some application areas.
Medical engineers, sir?
Biomedical engineers.
Biomedical engineers.
Intelligence, AI, in their domain.
Okay, biomedical engineers, I think you could go with modeling in here. And as I've told you earlier, we have a lot of applications of AI in the health sector. So let me just give you one application. Let's say, for example, for medicine and X-ray. A lot of studies I have noticed on cancer, on X-ray, on skull imaging, breast cancer. Most of the studies I have seen in the in AI field that I have reviewed so far, they are on the personalized, let's say, for example, medicine, X-ray readings, imaging, and then let's say, for example, you can go with image processing on food for diet. So you could go with. I hope I will be able to answer that question. Also, identification of plants and animals or fruits, okay, and how do they react with the food chain, and also modeling of microorganisms and viruses. You could easily identify using this convolution neural networks. So those are examples we could go with the health or the medical background.
Thank you, sir. That's all from the question side, sir. And once again, I thank you very much, sir, for your participation and accepting our invitation as a resource person and enlightening us in the area of artificial intelligence. So we got enlightened, the GMRITians, as well as a wide group of participants online through YouTube channel, sir. Thank you very much, sir.
Thank you so much for the invitation. It's a great honor and pleasure for me to be part of this wonderful endeavor. Thank you so much, Doctor, for the invitation. And I would like to thank personally the GMR Institute of Technology for the invitation. Thank you so much, and God bless you all. See you next time. Thank you so much.
Thank you, sir. Thank you very much. And there is a message to the participants. The afternoon session is scheduled at 1:30 p.m. So please log on to the YouTube link that is shared in the schedule. Thank you. Signing off. Signing off, sir.
Thank you.